Good evening, everyone. My name is Nosios, and today I'll present our research titled Theoretical Advancement in Logistics, Digitalization, Big Data, and Machine Learning in Decision Making. These technologies have significantly transformed the way logistics operations are structured, making them more dynamic, data-driven, and predictive. Throughout this presentation, I'll walk you through our key findings, focusing the evolution of logistics, theories, and the role of computational advancements in optimizing supply chain management. Logistics as a field has evolved significantly over the years. Traditional models like the economic order, quantity, and just-in-time were built on static assumptions about supply and demand. However, with digitalization and machine learning, logistics has shifted towards real-time decision-making, predictive analytics, and automation. This study explores how these technological advancements have redefined logistics framework, making them more efficient and adaptable to complex supply chain environments. Therefore, the main goal of this research is to analyze how digitalization, big data, and machine learning have influenced logistics theories and decision-making processes. Using a bibliometrics approach, we map out the key trends in this field, highlighting the most influential studies, emerging themes, and global research contributions. Ultimately, we aim to provide a clear understanding of where logistics research is heading and what gaps still need to be addressed. To conduct the study, we used bibliometric analysis, drawing data from Scopus, one of the most comprehensive academic databases, and we formulated a structured search query to identify relevant studies focusing on digitalization, automation, predictive analytics, and machine learning in logistics. Also, the Prisma 2020 framework was applied to ensure a rigorous and transparent selection process, and by using the bibliometric package INAR, we analyzed publication trends, citation patterns, and keyword concurrencies to identify the dominant themes shaping logistics research today. In this slide, you can see some of our descriptive statistics of the results. Our dataset consists of 264 academic publications spanning from 2014 to 2024, drawn from 201 different sources. The field has experienced rapid growth with an annual increase of 57%, reflecting the growing academic interest in logistics digitalization. The average citation count per paper is 20.78, demonstrating the strong impact of research in this area. Moreover, we found that collaboration is a key characteristic of this field, with an average of 3.34 co-authors per publication and 23.48% of papers involving international partnerships. This highlights the disciplinary and global nature of logistic research. In this figure, we have the annual scientific production, which shows the total papers produced over the years. Looking at research output over the years, we see a clear upward trend. From just a handful of publications in the early years, research in this field has grown rapidly, reaching at 91 papers in 2024. This increase coincides with advancements in artificial intelligence, predictive analytics, and digital transformation, which have become central to logistics operations. The sharp rise in recent years underscores how critical these technologies have become in reshaping supply chain management. The next graph is a keyword analysis of the dataset, highlighting the dominant themes in logistics research. The most frequently mentioned term is data analytics, with 59 mentions, reflecting the shift toward data-driven decision-making. Industry 4.0 and the Internet of Things also appear frequently, showing the growing integration of automation and interconnected digital systems in logistics. Other key terms like artificial intelligence, supply chain management, and predictive analytics further reinforce the central role of computational tools in optimizing logistics operations. Moving on, Figure 3 shows the trending topics in this field. Since 2020, there has been a surge in studies focusing on artificial intelligence, predictive analytics, and digital transformation. We're also seeing the rise of new concepts such as learning algorithms, intelligent warehouses, and advanced analytics, showing that logistics research is not only expanding but becoming more specialized. These trends indicate a move towards more sophisticated technology-driven logistic frameworks that rely on automation and real-time decision-making. Figure 4 is a co-occurrence network, and by mapping out how key terms appear together in research papers, we can identify major themes shaping logistics research. Our analysis reveals 4 primary clusters and 6 in total. The first one, the blue cluster, focuses on supply chain management and industrial automation, emphasizing the role of technologies like Industry 4.0 and big data. The second cluster, the red cluster, highlights predictive analytics and machine learning, showing how computational tools are being used to refine logistics planning. The third cluster, the green cluster, centers on digital transformation and decision making, while the fourth looks at cost optimization and automation. This thematic structure highlights the growing complexity and technological sophistication of logistics research. To sum up, our findings reveal a major shift in logistics from traditional static models to dynamic data-driven frameworks. The increasing reliance on artificial intelligence, predictive analytics, and automation is transforming how logistics decisions are made, with data analytics, AI, and predictive models driving theoretical evolution. And also the rapid growth in research output, which is 57% of annual growth, also shows that both academia and industry recognizing the importance of these technologies. There are several areas that require further research. First, predictive modeling techniques need to be refined to enhance logistics decision making. Second, more studies should examine the socioeconomic impacts of digital logistics, particularly in emerging markets. Additionally, integrating technologies like blockchain, Internet of Things, and artificial intelligence can improve supply chain transparency and resilience. Also, investigate long-term effects of automation and real-time analytics on supply chain adaptability and sustainability. And finally, there is a growing need for robust regulatory frameworks to ensure that automated decision-making in logistics remains transparent, secure, and ethical. To conclude, logistics is undergoing a fundamental transformation driven by digitalization, big data, and machine learning. These advancements are reshaping decision-making processes, making supply chains more efficient, adaptive, and intelligent. While there are still challenges to address, the potential of these technologies is undeniable. Moving forward, research should focus on optimizing predictive models, ensuring ethical AI use, and exploring new applications of these technologies in logistics. Thank you very much for your attention, and I look forward to your questions.